Okay, we have attendees popping in.
Good.
All right, take it away, Marty.
All right. Welcome to another podcast. Is this a podcast?
Webinar.
Welcome to another webinar from the Delphian School. We're here to make learning fun and to help you get excited and interested about finding about how the physical universe operates. That is, after all, the definition of science, the study of nature and how the world works. And my name is Marty Shaw. I've been a science teacher at the Delphian School for 25 years, and this is my assistant, James.
Hi, I'm James Galunas. I've been here for not quite that long, but still a significant length of time.
Okay, so we're going to do some demonstrations, a lot of which you can do at home. If you have a question, you can hit the Q&A button. Question will pop up, and James will choose some questions, and we'll see if we could answer them in the air, on the air. If you have a question about something other than the experiments that I'm doing, that's fine. Just send them in to James, and if he wants to, he'll let me know, and we'll see if we can answer them for you. I can't guarantee it, but we'll see what we can do.
We try to get to all the questions. It's not always possible. So usually if a bunch of people are asking a question, I'll pick one or two of them and we'll answer those to answer all of them. We've got some people saying hi. Hi, Isha, and hello, Sarah. Let's see, Hadia's here. She's saying hi. A lot of people saying hi in here.
Hi, hi, hi.
Kanan, Hartley. Hello, everyone, and welcome.
Absolutely. So I think for our first experiment, we'll do something with candles. Now, this is something you could do at home. And I'm just going to get a few candles here. Oh, I think 6 should be enough. And now I'm going to light them. James, I'm going to light one and ask you to light 3 of these.
You got it.
Light 3 of these. So now we have a few candles here. I hope you can all see that. And before we burn down the table, here I have some baking soda in this 1-gallon container. And here I have some vinegar. And what we're going to do is we're going to have a chemical reaction. Now, when this vinegar combines with this baking soda, you'll see lots of bubbles because there's carbon dioxide gas trapped in the baking soda, and the vinegar will release that carbon dioxide gas. Now, carbon dioxide gas is heavier than air, so it's not going to fly off into the room. It's going to pretty much stay into our little container. And a fire needs 3 things. Do you know what the 3 things are that a fire needs? Can you think of anything a fire needs? Well, it needs something to burn. In this case, the candle, the wax in the candle. It needs air or oxygen. Oxygen is needed for a fire to burn. And finally, you need something to start it. And that's what the lighter was for. So now I'm going to take this container, which has carbon dioxide in it, and see if we can put out the fire without touching it like that. So what happened was the carbon dioxide, don't forget this is heavier than the air, I poured it and it came over here and it prevented the air from getting to the candle. Ooh, this one's smoking a lot. Ooh, that would be good for our next experiment. Let's see.
I gotta remember this next time I have a birthday. I can use this to blow out the candles on my cake without blowing on the cake with my own breath.
Right. So I'm going to light this again. Now, this time what should happen is I'm going to blow this out and you'll see, do you see this smoke? Well, it's really wax. So what I'm going to try and do is blow it out and then relight it. Let's see if you can see it. Did you see it? Did you see it jump? The flame jumped from the match back to the candle. Because sometimes what has happened in the past is there have been firemen thought that this was just smoke, and smoke can't light up again, but it's not smoke. It's actually wax in the form of a gas. We'll try that one more time, see if we can do it again. And I'm holding this slightly down. If you hold the match up a little, it could go out by itself. So if you hold it slightly down, it could stay on. Did you see it jump?
I did.
Me too. That was fun. As long as we have matches here, well, let's see if we can do some other things first. I'm going to put the vinegar back.
Well, Marty's setting up for the next thing here. I just wanted to make the general announcement that if you're going to do any of these experiments at home, if you're going to recreate any of these experiments, make sure you do it with a parent, with an adult there to supervise you.
And some of these experiments should be done outside. Here's one. Here's another one we could do with a candle. So I'm going to light the candle. Now you can see that there's this candle between the candle and me is this bottle. So I can't possibly, this candle is being protected by the bottle. So I couldn't possibly blow it out. So I'm going to come on down to this level and watch what happens. So why do you suppose that happened? Why do you suppose, even though the candle was being shielded or blocked by the bottle, why do you suppose the candle went out? If you think you know, you could send in a Q&A, and if not, I'll answer it later. Okay. Well, let's not get crazy all at once. Let's try this next. This is just a foam plate, and this is some bubble liquid. Now, if you don't have bubble liquid at home, you could get soap, like a dish soap, like Joy or one of those things, and some water, and you can mix it up until it'll do pretty much the same thing. So now I'm going to take a straw and put it in here. And this is going to be my wand. Let's see. I want a big bubble though. So there's a nice big bubble. And now what I can do is make a bubble inside a bubble. And there's a bubble inside a bubble. And the thing that I really like, you can move it around. And the thing that I really like about these bubbles is they reflect lights around you, and you're able to see all different colors. Can you see the different colors in here, James?
I can, and I hope this is showing up clearly through the webcast as well. I can see the colors on the video here. It might, for those of you watching on your phones, it might be a little harder to see the bubble inside the bubble, but I hope you can.
And when you get to do this at home, you'll certainly be able to see not only the bubble inside the bubble, but the different colors. I'm going to try that again. There's a bubble inside. Let's see if I can get a third bubble.
Bubble inside a bubble inside a bubble.
And I've done it.
Ah.
So let's see how many bubbles you guys can make and how many bubbles inside of bubbles you can make. And then, of course, when you're done, you can pop them all.
That's my favorite part.
That might be the most fun part.
We definitely have some answers about how you're able to blow out the candle, even though there was a bottle in the way.
Okay, what do we have, James?
Milo says the air goes around. Emmett saying the same thing. Let's see. Yeah, wow, a lot of people answering in here. A lot of them saying the air went around the bottle.
Exactly right. That's exactly what happened. When I blew, the air went around the bottle, and that's why it was able to blow out the candle. Now, before I make a mess, I'm going to put the top on this. And we'll keep with the theme that we have of balloons. So here's a balloon that I put in a bottle, and I'm able to do something unusual with this bottle and with this balloon. I'm going to take a deep breath. And I blew up the balloon, but what have you noticed?
Well, the balloon is still blown up.
Well, why do you suppose that is?
I'm going to guess because of science, but I think you're looking for something a little bit more
I was
specific than that.
For something more exact to explain this. And I'll show you. I'm covering up a hole that I have in the bottle with my finger. And when I let it go, now the balloon gets small. So if you just have a bottle without a hole, even though I'm blowing really hard, you can't blow up the balloon. Why do you suppose that is? Why do you suppose that even though I'm blowing hard on the balloon, I can't blow it up if I'm covering up the hole? If you think you know, send in the Q&A. And then I'll explain further how to do this. So with a hole in the corner of the bottle, I blow it up, and then I hold my finger over the hole. And so the balloon stays blown up. Now, if you have a bottle that's maybe more likely to collapse like that, it would probably get a little bit smaller, but this bottle has nice firm edges, and so it's holding the shape and not collapsing.
Yeah, looks like Milo has the right idea. He says the air has to escape.
Right, and so the air has to escape. That's why it won't blow up if I just push in here, because there's air in here, and air doesn't like to be, I don't have enough pressure to blow up and compress or squeeze the air that's in here. And so.
Yeah, Hartley says because there's already maximum air in the bottle.
Exactly, you guys are so good.
And Amelia says, cool. I agree.
Okay.
Yeah.
So now, once I hold it, why do you suppose the balloon stays blown up in the bottle? Because I'm not blowing anymore, and there's a nice big opening for the air to come out. So why do you suppose the balloon is staying blown up in the bottle? And why does it go out when I lift my finger off the hole?
Yeah, we have Jordan and Amjad saying air pressure. Yep.
Air pressure, that's right. So when I hold my finger there, now all the air went out when I blew up the balloon, or a lot of the air. So there's only a little air in there. So the air pressure here is equal to the air pressure in the bottle. Now when I let go of the hole, then air comes in, and the air pressure inside the bottle is more than inside the balloon, and the balloon deflates.
Exactly. There's a lot of you putting basically exactly what he said into the Q&A box. I can't answer every one of you directly, but it looks like you're all getting the right idea. Good job, guys.
Okay. Now we're going to do something else with the balloon. So
I'm going to take a moment. I'm just going to adjust the camera down here a little bit so we have a little bit more of the table
okay
in the shot.
Yeah,
There
come
we
on
go.
down, a little more.
A little more? Okay.
Sure. Okay,
There
good.
we go. There we go.
Thank you, James. So now I'm going to take this balloon and I'm going to measure it. I wrapped it around one end and, oh, where did my magic markers go?
We have other markers.
Oh,
We have
good.
dry erase markers,
Well,
including
this'll
a
work.
very big dry erase marker in case we want to write a big message.
That'll work. So I'm going to make this little mark right here, right where the balloon ends. Can you see that?
Looks like we can see it.
Okay. And now I'm going to put that back. And what do I have here? What is this?
These are cold packs.
Oh,
That's cold.
that's cold. And sometimes these cold packs could be used for to warm up also. So if you need them to be warm, some of them say hot or cold. So you can take them, and if you have an injury or whatever, you can put them on your hand or, you know, put them on your tooth if you have a toothache, I suppose. And so what we're going to do is we're going to take these and we're going to put the balloon on here. So the balloon is all sealed up. Air can't go in or out, but it is getting colder. I'm going to even take one and put it on top. So we have this cold surrounding the balloon.
Yeah, Mina says it will become small.
Why do you suppose it'll become small, Mina? You're right. But
Yeah.
why? Why? Let's see. I'll put it through here again. And I'll bring it around just like I did before, right through the middle. And look at that. It goes beyond the mark we made, almost encircling the balloon completely. I don't know if you can see that at home.
I think we can, yeah.
You could see it better if I didn't have fat fingers. How's that? So yes, you're right. And what would happen if I took this balloon and put it in hot water or warm water?
Well, we've got some pretty good answers here. Amjad says because the air gets dense.
Right.
And Adia says because the air inside gets smaller in the cold.
Right. So when the air gets cold, it gets smaller. When the air gets warm, it gets bigger. And that's what makes high pressure and low pressure. You might have heard the weatherman on TV talking about there's a high pressure area or there's a low pressure. What that means is when the air gets cold and it shrinks, that means there's more air per space, and that's high pressure. And low pressure is when it's hot and the air expands and there's not as much weight. And usually that hot air carries a lot of moisture with it. And so when you have a high pressure, which is cold, meeting a low pressure, which is warm and usually wet, and they come together, you get rain or snow or something like that. Okay. Let's see. This is an egg. Oh gosh, I thought I had brought in some colored markers here, but well, I see a couple of colors.
Yeah, we can use these.
We can use these. We'll do that in a minute. So yesterday I took an egg, I'll use this plate, and I put it in a container and I put vinegar in here. Now what happens is the vinegar reacted with the covering of the egg, the hard shell, and it created carbon dioxide bubbles until it ate away the whole shell. And this vinegar will also eat away at other things like seashells. Same material. Seashells are made of the same kind of thing as eggshell. And so I'm going to take this, and it still has vinegar around it. And what is this? strange looking thin material. What is this?
If I had to take a guess, I
Yes.
would guess that's the eggshell.
That's not the eggshell. No, actually, that's the membrane. There's a thin covering around the egg. Sometimes you'll see it when you crack an egg open or when you have a hard-boiled egg. There's this thin, clear membrane. A membrane is just a piece of cell that's very, very thin. And it's clear in an egg, but because it had vinegar in it, it turned white. And now this is the uncooked egg. But it looks like it's cooked.
Yeah, it looks hard boiled.
Yeah, because sometimes it'll get rubbery looking, but this is just what happens when the egg sits in vinegar all night. You could try that at home.
Cohen and Emmett got it right. They said membrane when I said the eggshell.
Oh, these guys
job,
are
guys.
so smart.
Yep.
Let's see. Ah, here's another thing we can do with a balloon. So this is called a hex nut. It has 6 sides. And if I take it and drop it in the balloon, like so, and then blow up the balloon, and then tie the balloon, I'll have a hex nut inside the balloon, like so. Can you see the hex nut?
Yeah, we can kind of see it there.
And
Yep.
so if I take it, what a strange noise. Why is it making that noise? And the faster I spin it, the higher the sound goes. Now, if I did the same thing with a marble, what do you suppose is going to happen? Well, we'll try it. I'll see if I can pop the marble.
Yeah, someone said the nut is rubbing the side and making noise. Emmett says it sounds like a motorcycle. Chris says it sounds like a bee. Yeah.
Yeah, it does. So let's see if I can get this marble in here. Got the marble started.
And Anya thinks that with the marble, there's going to be no noise.
Well, let's see. So I'm gonna take this, and if I can get my fingers out of here, we'll see. So here's the balloon with the marble, and a little noise,
A very gentle noise, but
but not
definitely
as
not
much as,
not the bee sound.
right, not as much as this. Yeah, it does sound like a bee.
I like that. Yeah.
Now, we're going to do a little experiment with a pin. You probably know what's going to happen if I push it in the middle. But what happens if I push this pin through at the end? What do you think is going to happen? Right at this end, or I could try another one at this end.
Kanan says it won't pop.
It won't pop, but this is a nail. This is a pin that's very sharp.
And others are thinking it's going to pop. The Q&A section is kind of split here between pop and don't pop.
Well, you know, this is how scientists learn things. They say, I wonder what would happen if, or I wonder why that happens.
Mm-hmm.
And then they do experiments and they find out. So I'm going to take this and put it right through. Can you see the little pins sticking out? And now I'm going to take it out. Nothing. Didn't pop. Now I'm going to put it in the very center here. It might pop. But it didn't. Huh, how interesting. I can feel a little. Can you feel it?
Yeah, just a little hiss of air coming
There's
out.
a little bit of air. So the reason, why do you suppose it didn't pop when I put the balloon through either end? If you think you know, send in the Q&A. In the meantime, I'm going to put it through the middle. And what do you think is going to happen when I put it through the middle? Of course, it's going to pop.
Boom.
Now, as long as we have this top popped balloon,
Yeah.
there's something I want to show you. So here's a look at the size of this hole. This is immense. Here's the balloon, and here's the hole that it made. It's a tremendous hole. So if I take this now and I put it through here, I can't even see that hole. Can you see that hole? Just maybe.
No.
Very, very tiny.
I can barely see that hole.
Why is it that the balloon made such a tremendous hole when it was blown up and didn't make much of a hole at all when it wasn't? And why is it that the balloon didn't pop when I put it at either end, but I put it in the middle?
So Elizabeth says it didn't pop on the bottom because the rubber was very thick at the bottom, and it popped at the top or on the side because of the thin material.
Exactly right. That's exactly right. And why did it not pop when I had it like that? Why did it make such a small hole here, but a tremendously large hole here? Why did it do that?
Yeah.
If you think you know, send in the Q&A and see if we'll see if we can read it on the air.
So Elizabeth says that was a big hole when it popped because the air rushed. But once you put the pin in after the air went out, nothing happened because there was no air to rush out to make a bigger hole.
That's exactly right. Air can push.
And Vanessa says, hi, Elizabeth.
Okay, so now, we'll try this. If you ever go to a wedding or something fancy, they have these wine goblets, and sometimes they're just full of water, like this one. And if you hold on to the bottom, like I'm holding here with my fingers, and you wet it, and you rub your finger what in the world is causing that to make a sound? And what happens if I add a little more water? Did you hear the difference? Let's see, I'm going to add a little more.
People are chiming in saying vibration.
Yes. So what happens is the glass is vibrating because I'm rubbing it with my wet finger and it's vibrating. And why is it making a difference in the sound? Why is it a lower sound, the more water I'm putting in? What do you suppose that is?
Yeah, a lot of people chiming in that it's vibrating.
It's vibrating,
Yep,
yes.
it sure is.
Vibrating is what causes things to make noise.
That's how we're making noise here, right?
Yes, if you put your hand on your throat and you talk, you can hear your vocal cords vibrating. That's exactly right. Now, let's see. We've done that. This over here, and I'm going to take this, and I think I'm going to use this. We'll do this next. So this is just a little cloth that I have, and I'm going to put it over this glass top, and then I'm going to take these markers, and I'm going to make a design. There's a little bit of green. And then I'm going to I'll show you what this design looks like when I'm done, but this is something you could do also. And now I'm going to try some black. Do we have any other colors?
Green, blue? Is it giant blue marker?
Sure. Okay, thank you. So this is what I have so far. Not very impressive. It's a good thing I don't have to survive on my artwork alone. So here is some alcohol, and this is the kind you could get at the store, like the isopropyl alcohol or something like that. And if I take it and I just drop it in the middle,
Okay.
some of the colors are spreading. I'll hold it up so you can see.
Yeah. They're spreading outwards.
They're spreading outward because the alcohol is carrying them and moving them, having them move away. So this is with cloth. What would happen if I tried it with a coffee filter? Let's see. I'm going to make these. Thank you. Oh, yeah, this is your turn.
Oh, okay. So now it's an art competition. I see.
Well, okay, sure.
Yeah. I also would not do well as an artist, I don't think, but we're going to give it a shot.
Oh, you're making yours circular. You should show these guys what you're doing.
Oh, yes, I will. And then we're going to do some of this.
Wow.
All right. So we've got, I noticed in your experiment how you dropped the alcohol here and it spread outwards. We've all seen, water drip onto something and it spreads out. So I figure it's going to drop here. It's going to spread outwards. So we'll see if the design will carry out with it.
Okay, there you go.
Here we go. It's spreading slowly. I noticed it's spreading more slowly with this than it was on the cloth. That's interesting.
Well, what would happen if you, I'm going to ask you to do, I don't want to say James, but come on.
I mean, yours looks way cooler.
Mine looks way cooler, but I use the cloth. Now, this is another kind of paper. I haven't tried it with this yet. This is
we can
called
try this.
filter paper. You're all excited. I'm going to let you do it. This is called filter paper. And what chemists use, if they mix two things together and they get, they want to separate the liquid from the solid, they pour it through here, just like in a coffee filter. They pour it through here.
Okay. Yeah, that's
it's
starting
changed
to
a little
spread.
bit. Yeah.
Yeah, definitely. All right,
Okay.
so we're gonna do a design here.
I have you. Oh, okay.
I do like this blue. I'm gonna mark that up again.
I thought I had some other things, but I don't see where they are.
Okay. I made a series of blue and red marks there.
Now, what happens if you, instead of putting the alcohol in the middle, what if you put it on one side? Want to try that?
Put it on one side and had it kind of run across like that.
I can hold it up at an angle if you'd like.
Good, and we'll drop it on the top.
Yeah, we're doing an experiment here.
All right, let's see. Yeah, that color's starting to run down now.
Yeah, I can see that.
I like that.
They look like, the reds look like upside down teardrops.
Yeah.
Or candy corn. I'm going to hold it a little closer to the camera.
There we go.
So you can see that.
Starting to run down there.
And here's this one. This one didn't so much. But this one, you could see how the colors spread out when I put the alcohol in the middle. Okay. Do we have any questions?
All right, we got a lot of people chiming in here, just kind of giving their input on what's happening with the. Adia has a good question. Can we use nail polish remover to do this?
Nail polish remover is mainly a chemical called acetone, and that would work also. Acetone's more expensive than the alcohol you can get at the store, but sure, it'll work too. You have to be careful because if acetone gets on, or nail polish remover gets on certain surfaces like this table, it might damage the table. So do it in the kitchen, in the sink, or on some other outside or something like that.
Yeah. Yeah, Isha says that you're a good artist. I agree. Yeah.
Well, shucks.
Yeah, it's moving like that because where you put the alcohol, it will move in the opposite direction.
Okay. So now we're going to try something a little different. I have some aluminum foil. And I forgot to
And
get...
Thiago says we're both good artists. Thank you. Yes. I said I'm not a good artist. You're right. Everyone is an artist in their own way. And I'm sure I could make... I used to do all kinds of little stick figure drawings. It's just been a while.
Okay. So here's a little bit of aluminum foil that I have, and I cut it in this unusual shape. And I'm going to take a couple of matches here, and I'm going to use this pair of pliers, and I'm going to take... Now, this happens to be green. Some other match heads are red that I've seen, but this is the stuff that burns. So I don't know if you can see what I've done. I've taken the green off.
I think we can see that on there.
Okay. And I'm going to try this. And I'm going to try a second one.
We're scraping off all the green stuff that lights up brightly.
Right. Now, the last time I tried this, I had a skewer, a round skewer, and I think it works better with a round skewer. But we're going to try it with this anyway, because I don't have a round skewer with me today. And I'm going to take this, and I'm going to put it all right by my thumb. Can you see right by my thumb? That's where I have all the green stuff. And then I'm going to take this, and I'm going to just try and wrap it. Nice and tightly. There's a little I missed, but okay, let's see what happens. If this doesn't work as well as I think, I'm going to get a skewer from the other room.
Okay.
So now I'm going to take this because I don't want it to come out this way. So I'm going to use these pliers to make sure that it doesn't escape, that nothing escapes from the top. And then I want to make sure this is pretty loose. Pretty loose. Okay, so now I'm going to put this right in here.
All right, someone was asking what's the green stuff. So these matches have a green tip when you strike the match and the top flares up with light. That's what we were scraping off. Other matches, it's red on the top.
Right.
Yeah.
And so I'm going to take this and let's see what happens. I'm going to light it here and let's see. Nope. James, would you go next door and get me a couple of skewers?
You've got it.
You know where they are? In the closet behind my desk?
Yep.
Okay. So let's see. We could do that again. Or, oh, I know what we could do. We could take a balloon. Here's one that's blown up already. This is the one with the marble in it. And I'm going to take this. I'm going to get another balloon that I have down here. Now I'm going to rub this balloon on my clothes. And when I do, it's going to develop a little bit. I'm going to get electrons from my pants onto this. And now, whoa! And now the electrons in the balloon are attracted to the string.
I leave you alone for 1 minute and I come back and you're doing magic.
I'm doing magic. I'm doing science. Okay, we're going to try that again.
All right. We're running a little bit low on time here, so I think this will be our final our final experiment here.
What about the whoosh bottle?
Oh, we got to end on the whoosh
We
bottle.
have to end
This will
on the
be
whoosh
the
bottle.
second to last
Okay.
experiment that we do here.
Okay, so I'm going to I'll see if I can do it quickly. So I'm going to take this out and I'm going to scrape this off. And while we're waiting, I can give you this. You can attach this to that with that.
Like so?
No, with a match attached
Oh,
for the whoosh bottle.
yes, of course.
You don't want to do that with your fingers.
No, you don't. All right.
Okay, so now I'm going to take this skewer.
And as the skewer is round and much
Right.
smoother, and the match was square and a little bit more rough.
Right, so now I'm going to try and put this around here. Make this as tight as I can. That feels better. So
Adia asks, is that foil? Yes, this is aluminum
this is aluminum foil.
Yep.
So now I'm going to take my pliers and just squeeze the end so there's no possibility that the gas escapes through this end here. And now I'm going to take this. I'm going to see if I can tighten that up a little. And I'm going to take it out and put this end, the pointy end, in. So now it should slide off pretty easily. Okay, we're going to try that again. I need those matches. Thank you. Hopefully. Okay, well.
Okay.
It moved. It moved. I have gotten these things to fly off. Maybe it was the red matches that are better. I've gotten them to fly off about 15 or 20 feet. You could try it at home and hopefully you'll get better results than me. Yep. Now, for our grand finale, I've taken some alcohol. Don't try this with anything other than the isopropyl alcohol or denatured alcohol that you can get at the store. And I filled up this 5-gallon container that James is getting. But I didn't fill it. I just put a little bit of,
there we go.
I just put a little bit of alcohol in here and I let the excess drain off. I had it upside down like that. Okay, James, so now you light the match.
We're gonna have it go that way. Okay.
Well, I'm gonna hold it. No, you'll see.
Yep.
And you're gonna put it right by the top there and watch what happens. And nothing happened. Whoa! That was awesome. So if you're gonna try, whoa, feel how warm that is.
That is warm.
So this is warm because the alcohol was a gas and that gas burned off. So only try this with adult supervision and remember use the denatured or the isopropyl alcohol And then I drained off, get that little beaker? What I did is I drained off all the extra. So I had it sitting in here for a few minutes and it drained off all the extra. So there was just alcohol fumes. Well, I hope you had fun and I hope you learned some things. And remember, curiosity is the cure for boredom. Have a great day. Bye for now.
Bye, everyone.